Hi guys, this is Gopika here, and in this video I'll be discussing the alternate proof of angle bisector theorem. And one proof we already discussed in the last video. This is a new way, or this is different way of proving it, and actually this is much simpler, and it's using the concepts that we learned in this chapter only. Only one property is there which we derive it or which we use that we have learned before. Okay, in the previous proof we were using 2-3 properties that we learned in standard 9th. Okay, but in this proof we will use mostly the properties that we learned in this chapter and one property that is of angle bisector. Okay, and let's start the proof, and before starting the proof let's see the properties that we will use. Okay, so in the textbook, after one proof of the theorem that is of angle bisector property of a triangle, they have given one column called for more information, and in that they have asked you to write another proof of the theorem yourself. Draw DM perpendicular to AB. The construction is from D you draw a perpendicular towards AB and a perpendicular towards AC. Okay, two perpendiculars. This is the construction part, and we have to use these two properties and write the proof. So let's see what properties they are asking us to use. The areas of two triangles of equal heights are proportional to their bases. This property we learned in this very chapter, right? And another property is every point on the bisector of an angle is equidistant from the sides of the angle. Okay, so if you see here, this ray BP is the bisector of angle ABC, and if you pick a point P, then P is equidistant from AB and BC. So PM and PN are of same length. Equidistant means if you draw perpendicular, then it will be of same length on both the sides. Okay, so these two properties we have to use and frame another proof for the same theorem. Okay, that is angle bisector property of a triangle. So let's see the proof. Okay, so angle bisector property of a triangle statement: the bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. The statement is same, and now the proof is different. So first is given triangle ABC, AD is bisector of angle A. This is the given part, and to prove AB upon AC is equal to BD upon DC. Okay, this is what we have to prove. Okay, I forgot to write the construction part. That also they have mentioned in the two more information part. Okay, the construction is draw DM perpendicular to AB and draw DN perpendicular to AC. And one more construction I have showed over here is from the vertex A I have drawn a perpendicular towards BC showing height h. Okay, so let's see what is the use of it. Every point on an angle bisector is equidistant from the arms of the angle. Okay, this is that property we just mentioned in the previous slide. So using this property we can say DM is equal to DN. Okay, this is our first point. Now in triangle ABD and triangle ACD, for ABD DM is the height and for ACD DN is the height, and they both have equal heights from point 1. If you have two triangles with equal heights, then their ratios of their areas are proportionate to their bases. This is the first property that we discussed in the last slide. So area of triangle ABD upon area of triangle ACD is same as AB upon AC. That is when DM and DN are heights, AB and AC are corresponding bases. Okay, so areas proportionate to bases is the reason of this, and this is point number 2. Now also same set of triangles, those two triangles, if you look it in this way, and if you consider BD and DC as their bases, then they have a common height, they have equal height h. That is from A I drew a perpendicular which is of length h, and this seems to be height of both the triangles. Okay, since these bases are collinear and one vertex is common, you can say they have common height or same height, that is h. Okay, when again with same height, the areas of their ratios of their areas will be ratios of their corresponding bases. So area of triangle APB upon area of triangle ACD is same as BD upon DC when h is the height, and when DM and DN are height, it is AB upon AC. So here LHS is same, So the RHS also should be same. So AB upon AC is equal to BD upon DC, and this is what we had to prove. So the proof is done. It was that simple. Okay, we are considering the same set of triangles in two different ways. In one, which DM and DN are heights, we take the corresponding basis, and in the second point, H is the height and we take the corresponding basis, and they match. And the key is the first property, that is every point on an angle bisector is equidistant from the arms of the angle. This property is the key part, which helps us to say that DM is and DN are of equal length. Okay, so the proof is done. So I feel this proof is much simpler than the previous one, but anyways, it's your preference, whichever you want to follow, and you just learn the proof. And there are chances that they might ask you to prove using BPT. If they ask you particularly to prove using BPT, then you will have to stick to the previous proof. Okay, otherwise you can use this proof as well. So depending, so go through both the proofs actually, and then that's it. Okay, so I'm done with this video. Okay, so thank you for listening to me, guys. If you like the video, please share it with your friends, and subscribe the Friendtor channel. Okay, bye, see you soon.